Hey guys, this is the 4.2 notes. This focuses on two types of triangles, isosceles triangles and equilateral triangles. So the first thing I'll go through is the isosceles, and then we'll go through the equilateral triangle. So isosceles triangles are triangles that have at least two congruent sides, at least two, right? And at least two congruent angles. Right, it could be three, right? But it has at least two. Okay, and there are two types of angles you'll see, right? Since it has at least two congruent angles, that means it had two base angles, right? Those are the congruent ones, and then it has one that could be congruent or not, right? And that's the vertex angle. Okay, so if we look at our diagram. Right. We have our two base angles right here that are congruent, right? So this is a base angle, and this is a base angle. Right. And right, we know they have two congruent sides, right? And those sides are the ones that are in between the vertex in one base angle and vertex in another base angle. Okay, and that vertex angle is this one right here. Okay, so right, that goes through the angles. Now let's think about the sides. So to think about the sides, right, it says the isosceles triangle theorem and its converse. Okay, so isosceles triangle theorem says if two sides of a triangle are congruent, then the two angles opposite those sides are congruent. What does that mean? So if here, so we have an if-then statement, right? So it says if two sides, okay, so we say this side and this side are congruent, then, right, the two angles, the opposite of the side, so opposite of this one right here is here, right, and the opposite of this side is here, then those angles are congruent. Okay, so if two sides are congruent, they're opposite angles. Opposite angles means the angle not touching the side. Right? See how this side right here, the angle not touching it would be here. So that would be congruent to this side right here. I mean that angle right there. Right? And also we have the converse, which is essentially the opposite. So if two angles of a triangle are congruent, then the sides opposite those angles are congruent. Right, so essentially it's just working backwards. Right, instead of given two congruent sides, we're given two congruent angles, and we can prove their opposite sides are congruent. Right, so right, if two angles of a triangle are congruent, right, then they're opposite sides. Right, so opposite of this one would be here, and opposite of this one would be here. They are congruent by the converse of the isosceles triangle angle theorem. All right, so now that we know those facts, right, we can actually solve for angle measures. Right, so we know some things about isosceles angles, so we can use that information and solve angle measures. Okay, so we have two congruent sides, right? So if we have two congruent sides, their opposite angles are also congruent. Okay, so, right, if we label these opposite angles, right, x, we can figure out their angle measure. We know from previous sections that all three angles of a triangle add to 180 degrees. So 78 degrees plus x equals 180 degrees, right? Because triangle angle theorem. All right, that's from last topic, I believe. Right. So we get 78 degrees plus 2x equals 180. We subtract the 78 to both sides. We get 2x is equal to 102 degrees, and then we divide by 2. So we get x is equal to 51 degrees, and right, we know x and angle C, right, are equal to each other, so angle C is 51 degrees. Right, so number 2, right, we're given again the two sides, right? So we use the isosceles triangle theorem, right? That the two opposite angles are congruent, right? So we can call them x. So we get x plus 86 equals 180 degrees, right? From our triangle angle sum theorem. 2x plus 86 equals 180 degrees. Subtract that 86 from both sides, we get 94. Divide by 2, and we get x is equal to 47 degrees. And we know q is equal to x, so 47 degrees. All right. All right, so now we can keep using the facts, right? So again, we know that angles are congruent, okay? The opposite angles of these congruent sides are congruent, so angle H is congruent to angle J. So let's write their formulas or what we're told they're equal to so that we can solve for x and then solve for these angle measures. So H is 8x, right? J is 6x plus 18. So we're going to set them equal to each other because we know they're congruent, right? Now we move the 6x over. We get 2x equals 18. So x is equal to, we divide by 2 to both sides. X equals 9. We want to find angle H, right? So angle H is equal to 8x. We know x is 9, so I'm going to substitute 9 in. So angle H is 8 times 9, or 72 degrees. And that's our solution. All right, and 4 is going to be similar, right? These angles are congruent, so we set them equal to each other. 2x is equal to x plus 30 minus the x over, and we get x equals 30. Now we're looking for angle M, which is equal to x plus 30. So we're going to substitute in 30 plus 30. So we get 60 degrees for angle M. Okay, so also N is 60 degrees. Right, and that's how we solve. In this section, we have another theorem that allows us to solve for certain side lengths and angle measures. This theorem is called the perpendicular bisector theorem. It tells us if a line or a line segment bisects the vertex of an vertex angle of an isosceles triangle, then is also the perpendicular bisector of the other side. So what does that mean, right? So that's just saying if, right, we have some triangle here, right, And we know it's isosceles, right? So isosceles tells us these sides are congruent and these angles are congruent, right? And say we put a perpendicular bisector, right? Meaning it cuts that vertex angle in half, right? If we put this bisector, right, that's the bisector, right? What that does is cuts this in half, so we get two congruent angles here, right? Because they're cut in half. We got to make two arcs, right? So if we're given that, then, right, we can also say, right, given the perpendicular bisector, it's an isosceles triangle, right? We can also say that these sides are going to be congruent. So that means those two sides are congruent, right? The two angles are congruent. Perpendicular bisector. All right, so using that theorem, right, let's put it to work in this example. It says, what is the angle measure of RSQ? So we're looking for RSQ. So we're looking for this angle right here, right? All right, so, all right, we know this is an isosceles triangle. So 31 degrees is also equal to this degree right here, right? So this needs to be 31 degrees. Right? Now, by the perpendicular bisector theorem, right, this side and this side are the same, so this is also 4, right? So we can answer what is PR. Well, PR is equal to PQ plus QR, right? And we just, by the bisector theorem, we know that PQ is 4, and QR we are given is 4. So we know that PR is equal to 8. Right? Now we just need to find RQS, or sorry, RSQ. Right? So, what we first need to find is the whole angle right here of PSR, right? And we can find that, right, because that is technically our vertex angle, and we have the two congruent angles 31 and 31, so we can figure out that vertex angle. So 31 degrees plus 31 degrees plus that vertex angle PSR is equal to 180, right? And then to find the RSQ, we just need to split in half because we have the perpendicular bisector that cuts the vertex angle in half. All right, so we get 62 plus PSR is equal to 180. So angle PSR is equal to 118 degrees. Right? And we're trying to find angle RSQ, which is equal to 1/2 of angle PSR. So 1/2 of 118. So angle RSQ is equal to 59 degrees. All right, now what we're going to do, so we've gone through the isosceles, now we're going to go through what an equilateral triangle is. Well, an equilateral triangle kind of sounds like equal, right? All triangles whose sides are all the same length. So, right, it means a triangle where all the sides are congruent. right? All the sides of it. Right? And then we have properties of equilateral triangles. It says an equilateral triangle is equally angular. Well, what does that sound like? Well, that's just saying, right? If a triangle is equilateral, then it's equally angular. Right? So if a triangle, right? If all the sides are the same, right, which means it's equilateral, then, right, all the angles are the same because it proves that they're equally angular. Okay, so that's the property of equilateral triangles, right? And the converse to that would be an equally angular triangle is, right, equilateral. Right, so if you're given a triangle that has all three angles equal, we know that all three sides are equal. Right, so if equally angular, then, right, the sides are also the same, so it's equilateral. Right, so just remember that. If all the angles are the same, all the sides are the same. If all the sides are the same, then all the angles are the same. All right, so let's look at this picture and trying to find all the measures of all the angles. Okay. So, we look, right? Triangle ABC is equilateral. So, all angles are also equal. Well, if all three angles of a triangle equal, what degrees they have to be? Have to be 60 degrees. 60 plus 60 plus 60 gives you 180. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. All right, so angle CAB equals 60 degrees, angle ABC equals 60 degrees, and angle BCA equals 60 degrees. Then, let's look at triangle ABD. Well, we see that two sides are congruent. That means the two base angles are also congruent, the opposite angles, right? So triangle ABD is isosceles. Right? So, right, how do we solve for this? Well, we are given one angle. CBD is 130. So CBD, this whole piece is 130 degrees. So we can find out what ABD is, right? Angle ABD is equal to 130 degrees minus the 60 degrees from the other part of that full angle. Right, so ABD is equal to 70 degrees. So this right here is 70 degrees, right? So if that's 70 degrees, we can label these ones as X, right? So X plus 70 degrees equals 180. So 2X is equal to 110 degrees, and X equals 55 degrees, right? So, right, here's the three from the first triangle. The second triangle, right, angle BAD is equal to 55 degrees, and also angle ADB is equal to 55 degrees. Right, so knowing we had an equilateral triangle and an isosceles triangle, we were able to figure out the measures of all angles in these triangles. All right, so what we'll do is go through 4 kind of extra examples you may see from like math Excel problems with worksheets that I kind of want to go through so that you have examples of us going through them before you do worksheets and math Excel problems. This first one's the base of an isosceles triangle is x. The length of the legs is 6 minus 4. The length of the triangle is 226. Find x. So we draw an isosceles triangle where these 2 sides are the same and 2 angles. Right? So we're given that the base of the isosceles triangle is x. The length of the leg is 6x minus 4. So this also has to be 6x minus 4 because they're congruent, knowing it's an isosceles triangle. The perimeter or total outside is equal to 226. So we just need to add the 3 sides together instead of equal to 226 and solve for x. So we end up getting 6x plus 6x plus x equals 13x. And then negative 4 plus negative 4 equals negative 8. Right, when you combine those all together, then we get 13x. We add 8 to the other side is equal to 234. Divide by 13, and we get x is equal to 18. Okay, so that's if you have a problem where it gives you the perimeter and the 3 sides. The next one says find the values of x and y. Well, we know these 2 are going to be congruent because that's isosceles triangle, right? We have the 2 sides are congruent, so the 2 opposite angles. Well, we can solve for, right, we can call this y as well. We can solve for y, right? We have a straight line here from angle 126 and angle y, right? So we have 126 plus angle y degrees equals 180 degrees because they're a linear pair. Right, so y is equal to 180 minus 126, which is equal to 54 degrees. Right, so these are both 54. And then we can add 54 plus x equal to 180 degrees. Right, so 54 plus 54 plus x equals 180 degrees, right, because of the triangle angle theorem. Right, we know all 3 angles of a triangle equals 180. So we get right, 108 plus x equals 180 degrees, and then we subtract 108 from 180, and we get 72 degrees for x. So y is 54 and x is 72. All right, so here's 2 more problems. This one says find x. So again, isosceles triangle, 28, 28. So what we can do is add all 3 together, all 3 angles together, and set it equal to 180 degrees. Right, so we get 5x plus 65 equals 180. We subtract 65 from both sides, and we get 5x equals 115. So x is equal to 23. And that's just algebra. We set it equal to 180. Right, that's the triangle angles theorem. And then the last one says find the side lengths for all 3 sides. Okay, so we need to, we know that these sides are congruent. Okay, so, right, we know AB is congruent to BC. So we can set them equal to each other. 8x minus 1 equals 4x plus 5. Subtract 4x to the other side, we get 4x minus 1 equals 5. Add 1, right, and we get 4x equals 6. So x equals 6 over 4, right? We divide by 4, or 3 over 2. Okay. Now, we need to actually find the side lengths. Well, right, AB is equal to 8x minus 1. So we're going to substitute in 3 halves for x to solve. 8 times 3 halves is 12 minus 1 equals 11. So AB equals 11. Well, if AB equals 11, we know that BC is congruent to it. So BC also equals 11, right? We said right here they're congruent. So they are congruent. And then the last one, right, is AC, 2x plus 11. So substitute in 3 halves for x. All right, so 2 times 3 halves gives us 3 plus 11. So AC equals 14. So AB is 11, BC is 11 because they're congruent because they're